Alright guys, so I'm going to use the video and then I'm going to record all the answers and how to do those problems here and post them of course in the review file. And that's going to be your review for the makeup too. And excuse me for guest appearing with my baby's voice. Occasionally my mom and my husband. And also I spent the whole weekend and the first 2 days of this week making the patio with my family. It was exhausting. I was in the sun all day. So my apology for not posting this early. But I mean, you should be working on those anyways, right? Okay, question number 1. So velocity of an airplane is doubled. Its kinetic energy will increase. Okay, so kinetic energy is half mv squared, right? So if you doubled the velocity, so it becomes half m double the velocity 2v squared. And you distribute the square, you get half m times 4v squared. So compare your new formula to your old formula. You have extra 4. That means your new kinetic energy increased 4 times. Okay. Next.
Mama.
Okay, question number 2. If a bullet of mass 25g moving with a velocity of 200 meters per second strikes a wall and go out from the other side with a velocity of 100 meters per second, find the work done in passing through the wall. Well, don't worry about it. It's too much conversion, and then it's a conservation of momentum. Then you have to, it's a conservation of momentum, and also you have to calculate how much kinetic energy was there. So you have to subtract the kinetic energy to find the work done. Too much time. So next question. All right. A block of mass that weighs 0.5 kilograms, so this is the mass, is moving with a speed, so that's the velocity 2 meters per second, on a smooth surface. It strikes another mass that is 1 kilogram, so that was m1v1, and then this is m2, and then they move together. Okay, so energy loss during the collision is, actually I explained this question in the previous video, but overall you have to use the conservation of momentum, which is p momentum, to find your v3. Then that is the velocity when they combine together, move together. And then you have to find your initial kinetic energy. Okay. And then you have to find your final kinetic energy once they move together, and you subtract. Okay. And then remember, your answer should be 0.34. Oh, sorry. The answer is 0.67. Yeah, can't trust my memory now since my baby's next to me. Okay. A 65 kilogram girl is running at speed of 2.5 meters per second. The kinetic energy of the girl is 150. So it's looking for kinetic energy, and kinetic energy is half mv squared. So all you have to do is plug in number. M is 65, V is 2.5, and then you have to find out if it's equal to 150. If it's not equal to 150, then it's false. I think I remember it's false. Okay. Next, as a ball falls from up high down to the ground, when it's fall from up, it's losing potential energy and it's gaining kinetic energy because it's moving faster and faster. So your answer should be A. Okay, next. And 65-kilogram cart is rolling along a level road at 9 meters per second. So this is the mass in kilogram, and this is the velocity, meter per second. The cart encounters a hill and coasts up the hill. Do you need to know the mass of cart to determine the height at which the cart will come to rest? Okay, so you don't really need to know the mass because basically it was telling you that the initial kinetic energy or mechanic energy, which is Ki initial, because when the cart is start rolling, it has no potential energy. Imagine this, right? And the car is right here when it starts. It's going up, right? So there's only kinetic energy and there's no potential energy. When it stops at the top to rest, that means it's not moving. So there's no kinetic energy, but only potential energy. So kinetic energy is equivalent to the potential energy at the end. All right. So you don't really need to know the mass because if you write your equation out, kinetic energy is half mv squared, right? Equal to potential energy is mgh. Since the mass of the cart is the same, m and m can cancel out, so you don't really need to know the mass to calculate. Okay? Next, number 7. Okay. I am going to give you roller coaster questions, but not that many. Okay? Let's just skip this one, and then we're gonna work on more roller coaster questions. Okay, let's just skip this one. Okay, number 8.